let's assume we have this graph right here. So in an AC capacitor circuit, we have this concept. We have our voltage graph, is as shown, right? That's kind of too big. Let me just adjust it. Okay, let's assume it's right there. Okay, you have your Vmax, and V negative max here. And your current can be graph like this. Where the x-axis is representing the angular frequency multiplied by the time. Here is your Imax. So the peak, every peak right here, this is maximum current, right? Imax. And here is Vmax. Here's our origin, and my drawing is not very accurate, but this is pi over 2. This is pi. Okay, so as you see in this diagram right here, your peak, your current reach the maximum value as pi over 2. So Imax at pi over 2 or 90 degrees. Where you have Vmax is happening at this value right here. My drawing is not very accurate, but at pi or 180 degrees. So we can see that in this AC capacitor circuit. So this is for AC capacitor circuit. We can see that we reach the maximum current based on this diagram right here. The maximum current happen 90 degrees. So between pi over 2 and pi is 90 degrees. Happen 90 degrees before before the Vmax, before your maximum voltage. So based on this diagram right here, we can say that the maximum voltage lags behind the maximum current. Therefore, maximum voltage lags. That's the term, lags, because it reaches the maximum voltage after the current. The current reaches the maximum value first, so it lags behind the maximum current. So based on that, we can actually draw a Phasor diagram for the capacitor circuit. So, Phasor diagram for capacitor circuit. So this is how we draw it. We have the XY axis. Okay, so our current reaches the maximum value. Green. It reaches the maximum value here, and this angle is omega t, which is coming from here, omega t. Okay, before the current, before the voltage, and the voltage maximum value Vmax equal to Imax times C of X, or knowing that V equal to IR, right? But here, in this case, it's a AC capacitor circuit. So instead of writing R here, we're writing X of C. Okay. And this angle between them is 90 degrees because I max is leads V max in this capacitor AC circuit right here. Knowing this is the positive direction. So that's the phasor diagram for our capacitor circuit. The phasor rotates in a counterclockwise direction about the origin. So this is counterclockwise direction. And the voltage phasor lags behind the current phasor by 90 degrees. So we can see this is 90 degree square angle. The voltage phasor lags behind the current phasor by 90 degrees, and means that the voltage is 90 degrees clockwise from the direction of the current. So it's behind, it's lags, voltage lags behind maximum current. So from that concept, let's do example 24.6. So example 24.6 saying that consider a capacitor circuit. So knowing when I talk about capacitor circuit, we instantly thinking about the Imax lead the Vmax, or Vmax lags behind Imax, because the current is reaching the maximum value before the voltage in the capacitor AC circuit. So this example, consider capacitor circuit in figure 24.7, which is a circuit with an AC source and capacitors. And this capacitors has the value of 34.0 microfarad. The maximum current, Imax, is 1.45 amps. And the frequency of the generator from the AC source, 60 Hertz as usual. At given time, the current flowing through the capacitors is, so at a given time, so instantaneous current is 0.95 amps and increasing. So technically, yeah, it's increasing and until it reaches the maximum value, right? So at a given time, your instantaneous current is 0.950 amps, amperes. What is the voltage across the capacitor at this time? So what is your voltage at this time volt? And we have the diagram, the graph was given. So this is the given phasor. Now Imax going that directions, right? And we have the angle theta here, and we also have Vmax. So this is how Vmax, this direction, no, Vmax is Imax multiplied by X of C. Okay, the angle here is 90 degrees. Imax is rotated in a counterclockwise directions. So since this angle between the x-axis, the Imax is theta, so this angle here is gonna be what? Theta minus 90 degrees, right? It's gonna be a negative angle. Okay. The question is, what is the voltage across the capacitor at this time? And we have the instantaneous current is right here. I equal to I max size of the angle, because this side is actually opposite, right? Opposite with the angle, so we will use size of theta. Okay, and our instantaneous V would be V max size of the angle, because it's opposite with the angle, size of theta minus 90 degrees. Okay, so we have that graph right here. So now we have to find the voltage across the capacitors. So before we can find the voltage across the capacitors, we have to find the theta, because technically the voltage, the instantaneous voltage V is V max size theta minus 90 degrees. And the reason why we have our I max is here and I instantaneous is to the left, but V max is here but V instantaneous is to the right, because the current rotates counterclockwise, but the voltage rotates clockwise directions in relative to the current. Okay, so we were not given the Vmax though. Knowing that Vmax can be found in this formula, right? We don't have the angle, so we have to find the angle. So to find the angle, we can use this. So I equal to I max size of theta. Therefore, the angle would be the inverse size of theta. I divided by I max, and that would be inverse sine. Your I is 0.950 amps divided by I max 1.45 amperes. Therefore, your angle would be for 0.9 degrees. This theta right here, 49 degrees. Okay, so now we find the angle. We find this guy. Perfect. Now let's look for Vmax. So Vmax is I max multiplied by the impedance of the capacitors. So Vmax equal to I max multiplied by R, right? Or we remember Ohm's law, V equal to IR. But now IR, our resistance is actually X of C. And our X of C is 1 over omega C, right? That would be 1 over 2 pi F C. Okay, so Vmax is gonna be I max I think I wrote it wrong. Oops. V equal to, oops, sorry, X of C, that's correct, and that is correct. 1 over omega C, 1 over 2 pi F C. Okay, so our Vmax gonna be I max 1.45 amps multiplied by X of C, which is this, right? 1 over 2 pi 60 hertz, and multiplied by 34.0 times 10 to the negative 6 farad. So that would give you Vmax the value of 113 volts. Okay, we got the maximum voltage, we got the angle, we got the maximum voltage. go back to this equation right here, we can find out instantaneous voltage. So instantaneous voltage is Vmax sine theta minus 90 degrees based on this phasor diagram that we have here, this colorful diagram right here. 113 volts, size of 40.9, yeah, minus 90 degrees. Therefore, the instantaneous voltage at the moment is gonna be negative 85.4 volts. So we can see that in the phasor diagram, our current is positive and increasing in magnitude, whereas the voltage is negative and decreasing in magnitude. So one is counterclockwise and one is going toward clockwise direction.